So, yesterday, how do we feel about doing that one problem? Should we go over that real quick a second first? Let's do that. The linear programming introduction problem. I just wanted you to do number one. Okay. Let me blow this up a little bit. Okay. Today you're going to start really working on the rest of this packet after we go through some notes, and then tomorrow you'll have some time in class to really work on it. But ideally, what we wanted to do, again, is we wanted to graph the first line, so we had 8 and 8, and we shaded down because 0, 0 worked. The second line, a few people had issues with this. Somebody browsed my big extend. Oh, it's good, I think. Anyways, a few people had issues with this in terms of the cover-up method, and they thought I just go to 10 and to 2 because that number is 2. But remember, we cover up, so y is 10. We cover up, so what do we do with that when we're trying to solve for the other point? How do I solve for x here? Thank you. In other words, if I cover this up, what do I do to solve for x? You divide. And some people were just putting 2 as their x-intercept. We had to divide that to get 5. That's why I have it here. And then again, that line shades down as well. What the double left region is, because again, it's first quadrant, so here and here, was just this section here, which gives you 0, 0, 0, 8, not 8, 0. Look at your paper. 5, 0, not 0, 5. And then this point here, which if you graphed it accurately, you can see it's at 2, 6. And that's how I got my other point. I plug it in. If you did not get to finish this, if you did not understand it, please copy this in. You're going to want this. Okay? And then, actually, I'm going to move on here in just a minute, so if you haven't copied it by now. You did have some time in class to work on it yesterday, so I'm hoping most of you at least got it done. Maybe check with somebody around you. Okay? All right. With that being said, any other questions about this number one? How many of you got it right? Okay. So what did we do wrong? Somebody's got to have a question if we didn't get it right. Go ahead.
Like the second one, second line, I forgot what was wrong. You did 10 and to 5. I did 5 to 10.
Oh, so
and then I shaded like up instead of down.
Right. So the big thing, and I like what you're saying, I appreciate you putting that out there, is that she knew it was 10 and 5, but she went the wrong way with which one. So maybe when we solve these, we should literally write y equals 10. We should literally write x equals 5, and then remembering that x should have the x known and y should have the y known. That's actually a good tactic. We should use that. Okay. And then in terms of the shading, some of us are still having a few issues with that. I know Mr. Borg told me that people did better on the inequality stuff than we did on the standard form stuff, and we're going to actually revisit that today a little bit as well. We'll get to that shortly. Anybody else? Comments, questions, stuff that you know you did something simple wrong? Okay, we'll move on. Back to the notes. Alright, so now we get into the real nitty-gritty of it. It's the story problems, the type of problems. And the first thing is, let's just read the problem, which you can't see. Mary is making small planters. Type A planter has 2 ivy plants and 2 mums. Again, we can't really see the ivy plant over there, but oh well. And type B planter has 3 ivy plants and 1 mum. Each week, Mary has 24 ivy plants and 12 mums available for use in her planters. In other words, we don't have more than that. So that's where our inequality comes in. I can't have more than 24. That's where that less than or equal to thing comes in. I can't have more than 12. That's where that less than or equal to thing comes in. Now the profit, that should be a key word right there. Underline that word profit. When you see that, objective function. Every time. Objective, objective, objective. Okay? And we'll get to that shortly. But that should signify, well, it says $9 that she gets in profit for type A and $7 for type B. How many of each should she make to maximize her profit? So the first thing I want you to do is let's go down to this table here and just start filling in some things. Number one is telling us right here the first step to define variables. Now if we go back to the previous page, we talked about that. The first step is to define variables. And it's actually giving them for us. X is the number of type A's, y is the number of type B's. So look, the number of planters, X was the type A, y is the type B. Go ahead and write that in. Now the total is just x plus y. I'm not even worried about writing that in there. That's just, I mean, we add them all up, right? That's the total, okay? But that really doesn't have anything to do with what we're trying to accomplish here in this problem. What else do I know? Well, planter A has 2 ivy plants and 2 mom plants. So look, planter A has 2 ivy plants and 2 mom plants. Going straight down there. And if I really want to, I could keep going. The profit for the type A planter, it says it right here, is $9. Now let's go to the planter B. Nothing crazy here. Has 3 ivy plants and 1 mom. So planter B has 3 ivies and 1 mom. And it says right in the problem, a $7 profit for that. So the total here, first of all, the profit one is easy. It's just P, right? $9 per plant A, $9 or $7 per planter B adds up to my total for my profit. Now in terms of the ivy plants and the mum plants, well, look right in the problem. Each week, Mary has 24 ivy plants. Again, can we go over 24? No. So, 24 is the total number of ivy plants. Again, we can't go over it, so let's just write less than or equal to in there. We got a number of mum plants, cannot exceed 12. Okay, so let's put less than or equal to in there as well. Now our objective function, if you look back, and you don't need to look back right now, is always an equation. And again, it deals with profit. We know what our profit is. It's $9 per planter A and $7 for planter B. Can anybody give me the equation for our objective function? I'll even start.
So it's 9x
Keep going.
plus 7 or plus 7y?
Equals B. It's that easy. 9x plus 7y. Why did you put x with 9 and y with 7?
Because that's what it is.
Because that's what each of them are, right? It was $9 for plan A, it was $7 for type B, okay? So that's exactly it. Don't overthink the objective function. It is an equation, an equal sign, and they're usually given to you right in the problem as long as you know which variable goes with which one, okay? The constraints. The constraints are always, maybe we should write this, inequalities. So I better see like less than, equal to signs, greater than, equal to signs, etc. Okay? And we're going to come up with quite a few here. The first one is, well, anybody think they see it? Think about what we kind of did with our profit, but now we're talking, let's just talk about the number of ivy plants.
24.
How many, yes, there's a total of 24 or less, right? We can have less, we can't have more. Anybody think they see it? I bet once I give you the first one, you'll be able to do it from now on.
You divide it?
It is even easier than that. It is literally given to you right here. I have 2 ivy plants in planter A, plus 3 ivy plants in planter B, and combined, it cannot exceed 24 ivy plants. Okay. How do I say that mathematically? Well, simple as this. 2x plus 3y is less than or equal to 24. Move this up just a little bit here. So can somebody give me the other one? What about, what should I write for the number of moms? Keep going.
Is less than or equal to 12.
Boom, just like that. Here's what Trey said, 2x plus 1y less than or equal to 12. 100% right, okay? So again, once you fill in that table, and we know which one is x and which one is y, we can just read right across them. We've got our solution, our inequalities, okay? What else do I know? Can I have negative plants? No, that'd be silly. Because even if you put it in the ground, it's a seed, it's a plant, right? If we rebury it, it's still a flower in the ground. So, if we can't have negative, do you remember what we said, how we can write that if we can't have negative? What numbers are not negative? 0 and all the positive numbers, right? How do I say that mathematically? X is what? Greater than or equal to, because you guys said 0, right? We could have 0. Greater than or equal to 0. Simple as that. And it's the same thing for y. Greater than or equal to 0. And that's going to show up a lot. A lot. Unless I give you a requirement, like we have to have at least 2 of each or something like that. But it doesn't say that here. Okay? So now I can go, okay, I've defined my variables. I've written my objective function. I've written my constraints. What do you think I need to do next?
Plot it.
Yep, plot it, graph it. Okay? So let's go down below. If you'd like a ruler, there are rulers up here. Okay? If you have your straight edge or whatever, your ID, use that. On the left and the bottom here, because I know it's going to be in the first quadrant, let's just use those as our straight, as our y and x axis. So I'm going to use this as my y, and I'm going to use this line as my x. Probably should use the straight edge, especially when I have one right next to me, but oh well. So this is y, and this is x. So that kind of covers x is greater than or equal to 0, y is greater than or equal to 0. I don't have to worry about anything in the second, third, or fourth quadrant because I don't have any negative numbers. Okay? So again, you should have those 2 lines graphed. Okay. Now what? Let's go graph the other lines. How do I graph? Well, you know what? First we should probably label it, right? So on this problem, I think we can go by ones and we're okay. So every 5th box, just put a 5, 6, 7, 10. Same thing here. 5, 10. So that I know what's what. If you need to do something else, like if you have to go up by 2s or up by 3s or 4s or 5s, that's why we label this. Okay? Now, in terms of graphing that first line, well, you guys tell me. How should I, think back to what we just got done talking about, how should I graph this line? What do you think?
Take 22 divided by 24 and graph it down on both sides.
Correct. Just like what we've been doing. Use the cover-up method. Just like what I just said. Divide this by 2 to get my x. Divide it by 3 to get my y. And then I'm going to do the same for the other line. But let's do it one at a time here so we don't get confused. So the first one, I'm going to take x to be 12. Again, because I'm just going to set 2x equal to 12. Or to 24, excuse me. And y to be, well, anybody? What's 24 divided by 3? 8. Now let's go plot those points. Now keep in mind again, what means what? The x-axis gets the x point. So 12 goes right here. 8 goes right here. And connect my dots. Let me do that a second here. Try and again be as accurate as possible. We talked about that yesterday, so you can possibly see your point of intersection easier. And while you're kind of getting that line in there, I'm going to test 0, 0. So I plug 0 in here, plug 0 in here. I end up getting 0 is less than or equal to 24. Up. So what does that mean? Shade towards it. So all of this stuff gets shaded. Don't go too dark now, so you're able to see. And technically, for that line alone, it goes past the axis on both. So if you do go over the lines like I do, because I'm not very good at drawing, that's okay. So we'll graph our second one. Well, let's talk about it. What is the x equal on the second one? 6, because again, I cover that up and divide and get 6. I cover that up and divide, and of course that equals 12. Okay, so I'm going to go to 12 on the y. I'm going to go to 6 on the x, and I'm going to do the same thing. Plot those two. Connect the dots. And look at how nice that is. Because first of all, again, I plug in 0, 0. 0 is less than or equal to 12. That works. So I'm going to go over here. And I can see my double shaded region. Hopefully you can see it too. It's this right here. Here to here. Here to here. Don't go too far. It's just this region right here. So once we get our inequalities, I think this stuff becomes fairly simple. It's just pulling the words out. Okay, we'll do it again on the next page. So now what? What do I have to do next? Anybody remember? Find the vertices, exactly right. Okay? So, what are my vertices? Well, you can see one clearly here, 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 and here. So of course I get 0, 0. Question was asked in 6th hour, connect with these in any order? Yes. Your vertices do not have to be in any specific
Wait,
order.
so vertices are corners, right?
The vertices are the corners, that's exactly right.
I thought it was a point.
Like within it?
No,
The points
like
go ahead.
12.
Oh, like what we came up with up
That's
top?
what I did for homework. That's what I confused.
That's why we got the vertices wrong. I get it. Okay, the vertices are the corners, good word to use, of the feasible region, of the double shaded region or multi-shaded region. Good call. So if you get a sec, maybe just go ahead and circle those two so we see that. Maybe I'll plot that point right there. So I got 0, 0. I got 0, 8. Careful not to put 8, 0. I got 6, 0. And anybody see what this other one is?
It's like half.
Look at your own graph, don't look at mine. What do you see? 3, 6? Is that okay with everybody? Yeah, you can see it right on there, right? Over 3, up 6, absolutely. 3, 6. All right, so we came up with our vertices. Anybody remember what we do with those vertices?
Yeah.
Plug it in to the objective function. That's exactly right. Okay? So right up here, let's write our objective function. It is p equals 9x plus 7y. And the reason that's significant is because I got to know what to plug into x and what to plug into y. I plug 0 in for both, I just get 0 plus 0, which is 0, of course. But for the rest of these, 9 times 0 plus 7 times 8. If you can do that math in your head, you don't have to write that down. You can just write 0 plus 56, which is 56 plus 8. Same thing here, 9 times 6 plus 7 times 0, which is 54 plus 0, which is 54. And 9 times 3 plus 7 times 6 is 27 plus 42, which is 69. You can see what our maximum is here. It makes a little more sense than the problem I did yesterday where it was like 8, 0 or something like that. A lot of times you're going to get it where it's going to be the point that has a little of each. And the maximum is how many of type A and how many of type B?
Was that 3?
3 and 6. Because that's our x and
And do
y.
we do it at 69?
At specifically $69. Okay? What do you think? Think it's that bad? Let's do another one. Okay? And this is about as hard as I'm going to make it for you guys. Okay? Even on your homeworks, except for there's sometimes a few other variables. Any other questions about this? How I did something? Okay. It's probably, I'm going to tell you because I've taught this enough, to know that the issue is being able to come up with the inequalities in the equations. But again, if you use the chart that I give you, well, that makes it a little easier. Let's take a look at the next page. So, we talked about this the other day. Okay, we talked about the problem with mixed nuts and the roasted peanuts. So again, you're selling these you are selling cases of mixed nuts and roasted peanuts. You can order no more than 500 cans of packages because that's all the room you got. Also, you have no more than $600 to spend because you're on a budget. How can you maximize your profit? So, what do we know? Well, here, first step is to identify variables. Are you guys okay just continuously using X and Y? I mean, it's probably easier than trying to actually use other letters and get confused. Let's just always use X and Y. Which one do you want to call X? Which one do you want to call Y? Does it matter? It really doesn't matter as long as you put the correct numbers with the correct variables. So just because the first one's X and the second one's Y and everything we've been doing so far, let's just call the first one X and the second one Y. And again, the total, this right here is not something that we're ever going to grade. We give you this to try and organize your thoughts. Okay? So, what else do we know? Well, how many units are in the mixed nuts? Look at the problem. How many units are there? Say 12. Right? It tells us right in the problem. There are 12 cans per case, right? So, there are 12 units per case of mixed nuts. Let's put 12 in there. How about the roasted peanuts? 20, says it's right in the problem. How many total units can I have? Read the original problem. How many total units can I possibly have? 500, right? If units are cans and packages, we said that. Can I have more than 500? No, so how should I write that? What have we been writing all along? Less than or equal to. That's exactly right. I love it. I'm getting so many people to participate today. Less than or equal to 500. Okay? How about the cost? Well, how much did it cost me to buy a case of mixed nuts? $24. Says it right in the problem too, right? $24 there. How about the roasted? 15. Anybody tell me what to write in the next one? Yes? What about it though? What's the sign going to come with it? Right, because again, I can't go over it, right? So less than or equal to 600. How about profit? What's my profit for the mixed? 18 tells us right there. How about the profit for the roasted? 15 again. And then, what am I going to put here? Remember what we just did on the previous page?
You put P.
P, because it's the total profit, right? It's the total profit is my P, okay? So, now I think we're starting to get this. Can somebody tell me the objective function?
P equals 18x plus 15y.
Perfect, right? They just got this on lockdown. How many of the rest of you saw that? We're starting to feel that? P equals 18x plus 15y. Now the only other thing that would have been different about that is if you had called one of them, the other one, like flipped x and y. Then you would have had 18y plus 15x, but we didn't do that, so I'm not going to get confusing. Your constraints, they're given right there in the problem. Take a second, and I'm not going to mess you up because you have everything you have. I'm going to just put this back up here to show you what I did. And I want you guys to try and come up with the constraints for the problem that we're working on right now. This is just the previous problem, so you can see how I use the table to make my constraints. See if you can do it for this problem. I'll give you a minute, maybe 2 times. Pretty easy. So again, what did I do in this previous problem? I just went right across. 2x plus 3y is less than or equal to that. 2x plus 1y is less than or equal to that. So similarly, what we should have on the next page is right across. 12x plus 20y is less than or equal to 500. 24x plus 15y is less than or equal to 600. Did you guys put any other ones? Or just those two? Are we going to deal with negative packages? Can you have negative packages?
No.
No. Can we have negative money? Well, I guess you could lose money, but in terms of this problem, we're not going to say, oh, just put it on my credit. We have to actually spend it. So x is greater than or equal to 0, and y is greater than or equal to 0. You should have also had those. All right. So I'm going to help you with these numbers because they get kind of gross. But let's go to graphics. Let's do the same thing we did on the previous problem. Use your left and your bottom corner, or edges here. And here's the thing. Well, before I even get into numbering it, I'll make sure you guys are caught up to there. and then let's talk about what the x and y are. But we're still going to do the same thing we've been doing. We're going to use the cover-up method, and you're going to want calculators maybe as we do this, not right this second, because I'm going to give you the numbers, okay? But let's talk about what x equals and what y equals for that one. Let's talk about what x equals and what y equals for that one. Again, if I use the cover-up method, like so, this works out real nice. 20 goes into 500. Anybody know? 25 times. So the y is 25. That one comes out perfect. The x doesn't come out so nice. I'll just tell you that. 500 divided by 12.
40.
Close, 41.6. I think
We
that's
got
right.
points?
Is it?
Yeah.
What's that?
We got half.
But don't worry about it. It'll be legit, I promise. I'll show you why. So 41.6 repeating is actually what it is. It's going to be easier to graph that than you think. I'm going to show you why in just a second. Yeah. Let's do the other one. Danielle, did you already figure out the other ones?
No.
Good. I'll just do it with you guys. 15 goes into 600. Anybody know how many times 15 goes into 60?
Yeah, 40, 25.
4 times. So 15 into 600 would be 40. And then 24 into 600, I don't expect anybody to know that off the top of their head, so I'll just do it for you. It's 25, actually. Which makes sense, 4 quarters and 100. Times 6 would be 25. All right, so from there, I've got my x and y's, but this only has 14 boxes on it. So I can't go by ones, because I'll never get any of those numbers in there. What if I go by twos? What's 2 times 14? 28. Well, that'll fit most of it, but those 40s won't fit. What if I go by threes? Could you go by fives? Yes, but I tell you what, the smaller the interval, the more accurate your graph is going to be. So if I go by threes, what's 3 times 14? 42. Oh, well that's kind of nice, because that'll get everything we need in it, right? So let's go by 3. So 3, 6, 9, 12, 15 will be the 5th mark. 3, 6, 9, 12, and then 30. We'll do the same thing going up. 15, 30. So the end we said is 42. That'll be on both. I don't know if you necessarily need that, but it sure makes that first x-coordinate be really, really, really nice to graph. Because if that's 42, 41.6 is like literally right next to it. Okay with that? Let's graph that in there. 41.6 repeating will be right next to 42, almost on it. And 25, well, let's go here. We got 18, 21, 24, 25 will be just above the line for 24. So you can see where 30 is, 27 would be the notch below it, so 25 will be right there. Connect my dots. And I'll slow down a little bit and let you guys catch up. I'm going to shade it though. And because if I plug in 0, 0, I get a true statement. And most times we are going to shade down. It's not all the time, but most times. So I got all that. And you guys can just keep going with your other ones, and then we'll see if we can get these points. So I got y equals 40. It's right about there. X equals 25. And again, 0 is less than or equal to 600 works, so I'm going to shade the red one down as well. And there you can see your double shaded region, which I'm going to color in a little darker. Be careful that you don't go too far. Now 3 of these points are going to be super easy. What's this one? 0, 0. Can you tell me what this one is? 0, 25. Right? We know that because we have it right here. Right? How about the red line's x value?
24, 0.
Yep. No, 25, 0, right? I think that's what it said. Now what about this one? Boy, you know what? As accurate as we can be, we're going to be guessing if we just come up with it.
That's
What does it
15.
look? What does it look like?
15.
15 what? Like what's your x and y? 15, 15? Okay. Anybody else? Think it's 15, 15? Is it a little higher? Is it a little lower? Hey, look, we missed the board. What a nice guy. Brought in Kleenexes for everybody? Bought him with his own money?
Where do you keep them?
Just up on the top is fine, sure. We'll take them down as we need them. All right, so if we don't know exactly what that point is, and I'm going to tell you it's not 15, 15. It looks like it's real close, but it's not.
14, 16.
14, 16, somewhere around there. Let's not guess though. Anybody remember what we can do to figure it out exact? Think back to the 6.2, 6.3 quiz where you had to do both sides.
Substitution.
Substitution or elimination. Now substitution in this case is going to be kind of ugly because we'd have to solve one of those for x or y. But what do you think I could do to that top line to be able to get something to cancel out with the second line? What if I times this line by -2? Well, I'm going to get -24 and 24 to cancel. I'm going to go write it down here. -24x minus 40y. I'm not even worried about the sign. I'm going to write equals because I'm just trying to solve for a point here. Equals -1000. And 24x plus 15y equals 600. It's okay to get negatives. These cancel. -25y equals, I'm just writing this out instead of having you solve it for the simple sake of giving you enough time here. And divide. And y is 16. David, you called that. Let's go back to this and write 16 in here. What do I do to find the x value? Remember?
Plug it in.
Plug it back in, right? Does it matter which one? Nope. But I know that 20 times 16 is pretty easy because I know 2 times 16 is 32. So I'll plug it back into that one. 12x plus 20 times 16 less than or equal to 500. Again, I'm not really concerned with the less than or equal to sign. I'm writing this kind of small, but 12x plus 320 is 500.